Alright, so I think I'm recording. Let's take a look at this problem. We've got Bob, which of course is Robert Morris, shooting an arrow from the top of a 120-foot cliff. The arrow's distance above the ground below can be modeled as a function of time in seconds. That is h of t, and h is for the height. H of t is equal to negative 16t squared plus 96t plus 120. When will the arrow be 180 feet above the ground? So we have the ground, we have some kind of a cliff. That cliff is 120 feet tall. You've got Robert Morris that's shooting arrows at Rupp Arena. Yeah. Alright, so the path of an arrow, that's a terrible looking arrow, that's follows a parabolic path, and it's nicely modeled after a quadratic function with the leading coefficient negative. The parabola opens downward, so you can kind of see the shape of the parabola here. Unless the 184 feet is at the vertex, the maximum height of the arrow, what we suspect is that after you shoot the arrow, since you're already at 120 feet, the 184 feet is probably going to come pretty quick. After you shoot the arrow, on the way up, the arrow will be 184 feet above the ground. It'll go up and reach some maximum height, and then on the way back down again, it'll pass through 184 feet above the ground again. So being a quadratic, we expected two solutions, and we're going to be able to keep both of those solutions, and they make sense within the context of this problem. So as soon as you kind of understand what the problem is stating, it's fairly easy, because the 184 feet is the height, and that's the left-hand side of the equation, and now you just have a quadratic formula to solve. You've got 184 negative 16t squared plus 96t plus 120. For any quadratic formula, whether you're going to try to complete the square quadratic formula or factor, you want to get it in standard form. So I want to subtract 184 from each side. And I notice that all of these are divisible by 16. So actually I'm going to divide them all by negative 16 just to get a positive leading coefficient. At least I think they're all divisible by 16. What's 96? Yeah, 6, right? Yeah. So I don't see this factoring, because I can't come up with two numbers that multiply together to give me positive 4 to add up to negative 6. So I'm going to use the quadratic formula. Let's identify A, B, and C. And give myself a little bit of room. So I've got the opposite of B is 6 plus or minus the square root of B squared, which is 36 minus 4 times A times C, all divided by 2A. So I've got 6 plus or minus 36 minus 16. That's the square root of 20. 20 breaks down to 4 and 5, and the square root of 4 is 2, and I can't simplify the square root of 5. So the square root of 20 is 2 radical 5 divided by 2. That gives me 3 plus or minus radical 5. So let's get decimal approximations for that. If I have 3 minus the square root of 5, so 0.76 seconds if I just rounded 2 decimals. So almost immediately, since you're already at 120 feet, almost immediately after you shoot the arrow, in under a second, that arrow has reached a height of 184 feet above the ground. When at t equals 0, you were already 120 feet off the ground. And now if we change this subtraction to addition, so you go up, and then what goes up must come down. And about 5.24 seconds after you've shot the arrow, again the arrow is going to be 184 feet above the ground, but this time it's coming on its way down to hit your target at Rupp Arena. Alright, so I hope that helps, and I'll talk to you later.